So in this video, we'll be going over the integral test to check if a sequence or a series is converging or diverging. So let's start with a simple example to understand what is the integral test and how do we use it. So let's say we have n is equal to 1 and it goes all the way to infinity, and we have a of n. So now we can rewrite this in terms of the integration from 1 to infinity of a of n, which we can write in terms of f of x. So here a of n is equal to f of x, and we are integrating in terms of dx, so x. And as we know, we cannot have an integral in the limits. So here what we need to do is we need to replace this infinity by a variable b, and we take the limit of b is approaching infinity. So now if this integration gives you a finite number, let's call it L, this means that this sequence is a converging sequence. Now if you have either plus or minus infinity as your answer of this integration, then your sequence is diverging. Now you might be thinking that this test is so simple. We can literally find any sequence or series in whether if it's converging or diverging. The only downside when you cannot use the integral test is when you have, let's say, the integration of x of factorial, a factorial function basically. So let's call it n factorial. You don't know how to integrate a factorial, right? It's impossible. So that's one thing to keep in mind. Now let's do some examples. So here let's take the p series which we discussed in our last video. So let's have the sigma, the series from n is equal to 1 all the way to infinity, and we have 1 over n to the power of p. Now we have three cases in this. So where the first case is p is equal to 1, and we know from before that this is called harmonic, and this is diverging. Now the second case is p is more than 1, and the third case is p is less than 1. So we will be looking at these two cases with the integral test, and this entire thing is called p series. So our first case is going to be p is more than 1. So we have the series n is equal to 1, infinity 1 over n to the power of p, and let's just replace this now. So it's going to be limit from b is approaching infinity, sorry about my handwriting, and we have the integration from 1 to b of 1 over, we replace n with x and the p stays the same, of d of x. Now how do we integrate this? We are gonna bring x to the power of p above in the numerator, so it becomes negative p, and to integrate this is gonna be plus 1 over negative p plus 1. So now let's write this below here. So it's gonna be, I'm not gonna repeat writing limit, so it's gonna be the limit from 1 to b of x to the power of negative p plus 1 over negative p plus 1. Now let's replace b. So it's gonna be, b, x with b, so it's gonna be b to the power of negative p plus 1 over negative p plus 1 minus, now replace x with 1, so it's going to be 1 to the power of anything is 1, so it's going to be 1 over negative p plus 1. So now let's erase this part over here. Now all we left here is this thing, and don't forget that we do have a limit, which is limit of b is approaching infinity. Now if you look here, we have b to the power of negative p plus 1. Now, what is the power, or what is the sign of the exponent over here, the power of b? It's going to be negative, right? So b to the power of negative p plus 1. Let's take a p as, let's say, 5 here. So it's going to be b to the power of negative 5 plus 1, which is equal to b to the power of negative 4, which can be written as 1 over b to the power of 4, right? And you might be thinking why I took 5, because we know that p has to be more than 1. So it has to be 2, or even like positive infinity, or some huge number. Also, we know that b here is approaching to infinity, right? So if we take the limit of b is approaching infinity over here, what will you get? It is 1 over infinity to the power of 4. So it's like 1 over infinity, which is equal to 0. So this entire part here is 0, right? If we think about it. So once again, if you didn't understand, let's go over it one more time. So here we know that p is more than 1. So it could be 2 or greater, right? So let's take this numerator separately. So here we have the numerator as b. So let's write it over here, to the power of negative p plus 1. Now b we know is positive infinity, so let's replace that with positive infinity. And negative p, we know that p is more than 1. This means it's either 2 or all the way to positive infinity. So we can take any number from 2 to positive infinity. Let's just take 2 for the simplicity. Negative 2 plus 1 is negative 1, and we can write a fraction to the power of a negative power in terms of 1 over infinity, right? Pretty simple stuff. And the power of infinity is just 1, which we can also remove. Now we know that any number divided by infinity is equal to 0. So this entire thing, the numerator here, is equal to 0, right? Pretty simple. And 0 divided by any number is also 0. So this entire thing is going to be 0. So now all that's left here is going to be negative 1 over negative p plus 1. So let me just bring this closer. Now the limit does not matter since we don't have a b variable here, and we know that p is more than 1, right? So now, is this a converging or a diverging fraction? It's going to be, of course, a converging, since we know that p is going to be more than 1. So it could be, let's say, anything from 2 to, again, positive infinity. And if you try any numbers, you will get a finite number. So you will get maybe a 0, but you will never ever get negative or positive infinity. So the final answer for this question is that it is a converging series. So once again, let me just go back to the question. So again, we replaced it with integration with from 1 to b, where b is positive infinity. And if we find that this integration is a converging number, this means that the series or a sequence is also converging. If we are finding that it's positive or negative infinity, then this series is also diverging then. And once again, you may not get an exact answer here, as we do not get an exact answer. We just need to know the behavior, that if it's a converging integral, or a diverging. And that's how we find out the behavior of this sequence. So now let's do the same question again, but this time p will be less than 1. Less than 1. And all the steps of the integration and the substitution are the same. So I'm just going to rewrite this part over here, which was b to the power of negative p plus 1 over negative p plus 1, and we have minus 1, this fraction over here. And let me just erase this. Now don't forget that we have a limit of b approaching infinity, and this time p is going to be less than 1. So let's again take this numerator, which is b to the power of negative p plus 1, and let's take any value less than 1 for p. So let's take 0 for p here. So it's going to be 0 plus 1, which is b to the power of 1, and here we know that b is approaching infinity. So infinity to the power of 1 is going to be infinity, right? And it does not matter if we have a finite number over here, since we don't have a b inside there. So it's just going to be infinity minus a finite number, which is equal to infinity, right? So the answer for this is going to be infinity, and therefore it is a diverging, I spelled that wrong, series. So again, you can take any value for p here less than 1. So even 0.9 is going to be negative 0.9 plus 1, which is 0.1. Now infinity to the power of 0.1 is still infinity, right? You can type a very large number to the power of 0.1, it will still give you a very large number here. So again, the same thing, and it will be diverging. So now let's move on to more complex or difficult questions. So our next question is the series from n is equal to 1 all the way to infinity, and we have 1 over n squared plus 1. So first step again, let's replace the series with the integration. Limit from b is approaching infinity, and the limit for the integration is 1 and b, and we need to replace n with x here. So it's going to be 1 over, sorry about that, 1 over x squared plus 1 dx. And from our last videos, we know that this replaces the integration of this fraction. 1 over x squared plus 1 is tan inverse. So you can check that video out. I have made it. So it's going to be tan inverse x. And now we need to take the limits from b and 1. So this is going to be equal to tan inverse of b minus tan inverse of 1. So don't get confused between the brackets. Oops. So now we know that b here is approaching infinity, and let's just quickly draw the graph of tan inverse. So we have a graph over here. This middle point is 0. This upper point is, let's call it pi over 2, and the bottom part is also negative pi over 2. Since we know that the most minimum value and the most maximum value for tan inverse is negative pi over 2 and positive pi over 2. Negative. And we can just replace, do this on the calculator. If you just type tan inverse 1, it's going to give you, let me just do it here, pi over 4. And the most, what we have over here is tan inverse of a very large number, so positive infinity. But here we know that the graph just goes like this. It never goes above pi over 2. So the most maximum value of tan inverse here is pi over 2. So you can also just do this on the calculator, by the way. Just try typing tan inverse of 99. It will always give you pi over 2. If you try 999, it will always just give you pi over 2. And pi over 2 minus pi over 4 is equal to pi over 4. And this is a converging series. So question 2 is the n is equal to 1, infinity, and we have the fraction of n over n plus 1. Now here sorry about that, n over n plus 1, we can either use the integral test, but it's going to be a long way. So there is a simpler way which we can just directly use the nth term method or test that we call. And I think I have made a video on this, by the way. Here you can also use the integration test, but integrating this and it's more complex, and when you have a simpler method you should always use that. So the nth term test says we just take the limit from n is approaching infinity, and we take this part, so n over n plus 1, and here it's gonna give you 1, which is not equal to 0. This means it is a diverging series. And if this result was equal to 0, then you don't know, it's indecisive then. But if it's equal to any value except 0, then it's a diverging series. So this is what the n term test is. You also should know these. Now our next question is going to be sigma of n is equal to 1, infinity, and ln n over n. So here we need to use the integration test. So let's replace that. Limit of b is approaching infinity from 1 to b, and here let's take ln x over x dx. So now you just normally integrate this. I'm going to use u substitution over here. So here you can just take u as ln x, du is going to be 1 over x dx, and this part is going to cancel out this part. So all you're going to be left with is integration from u du, and that's going to be u squared over 2, and I'm just going to replace u here with ln x. So let me just write that over here. So we have the limit from 1 to b of ln x squared. Don't forget that it was u squared, so it's going to be ln x squared over 2. And now we just need to plug in the values, the limits. So here let's replace the two values, limits. It's going to be ln b squared over 2 minus ln 1 is and as we know, ln of 1 is just 0, so we can just forget about this part. So all now we're left with is ln b squared over 2. And now we need to replace b with infinity as from before. So limit from b is approaching infinity, and we know that ln infinity is in infinity, and squared again is also infinity. So this part is equal to infinity. This means it is diverging. Diverging. So that's all for this video. I hope that you understood, and if you have any questions about any of these questions, you can always ask in the comment section. I'll be more than happy to answer. And as always, I do have a shortcut method for you guys on the calculator to recheck your answer. So if you have the sigma or the series option on your calculator, what you can do is you can just type this entire equation, and instead of putting infinity, you can try with, let's say, 9 first, and let's say you get 2 as the answer on the calculator. Now when you try with 99, you will get, let's say, 4. So you can see that it is graduatingly increasing, and when you will put 999, it will be even a bigger number. So therefore you can directly say that it is a diverging answer. And again, the same thing for this question. If you start by putting infinity by 9 again and slowly increasing it and seeing the behavior of the answers, then you can tell if it's increasing, then it's diverging. If it's decreasing to 0, then it is converging. Now if it's decreasing to negative infinity, that's also diverging, right? So you need to be smart about it, and you can always use this method after solving the question to recheck your final answer. And in my next video, I'll be making the comparison test for the same sequences in series. So stay tuned for that, and thanks for watching.